Hey, it's Random Code here, and today we're going to continue with the Advent of Code series, where we're now at day 4. And day 4 is not too complicated, and the case today is that we have these kind of cards, where the card have some winning numbers, and the drawn or picked numbers. And then we simply just need to count how many numbers on the right side are also on the left side, so how many numbers are winning numbers. And then we do a small calculation, adding some points, where 1 point is 1 point, 2 correct is 2 points, and then we keep doubling, so 3 correct is 4 points, 4 correct is 8 points, and so on. And that is very much the case. So as always, I have a input file where we have a lot of these cards, and we then simply read them in. I have then created a find winning numbers method. So we have the winning numbers and the game numbers, and if we look at an example, we can see that first of all, the text of the card and all the numbers are separated by a colon. So we split first on colon and take all the numbers. The next step is then splitting on a pipe or a straight line. And we then, for the winning numbers, get the first set, so the set left of the pipe. And for the game numbers, we get the first set or second set, index 1, so the right side number. We then trim them, so meaning we're removing any extra spaces on the left or right side. We then replace double spaces with a single space because single digit numbers like 6 or 8 is actually not 6 or 8, it's actually 0 or empty space 8, empty space 6. So we remove these, which then allow us to simply split on empty space to now get the numbers. We then pass them as integers. We have a list of integers and then we send them to a list. We can then very simply, to get the winning number count, simply do our game numbers, streaming.filter, and then only keeping the numbers that is also contained inside the winning numbers list. And then we simply just count them. So this is actually quite simple. Find all winning numbers, find all game numbers, filter them to have numbers only in both lists, and count. Then get the points. I have created a small little recursive calculator for this, where we have recursion, meaning if our winner count is 0, just return 0. If our winner count is 1, just return 1. If it's going to be larger than 1, we're going to return the get point, so calling itself recursively, with the current winner points minus 1 multiplied by 2. So if we input 1, we just get 1. If we input 2, we first get the winner points type 2 multiplied by the winner count of 1. So it's going to be 1 times 2, 3 is going to be 1 times 2 to 2, and so on. So a small little recursive calculation for the points. Could be done simpler, but I thought it'd be kind of funny to do a little recursive method. So then I actually get the result. We very simply just read our input from our input file as a list of strings. We then run through each element, find the winning numbers for that specific list, then calculate the points from the amount of winning numbers for each list, and add them all together. And as always, we can run it, but it doesn't showcase much. And as mentioned, this first task is relatively simple. Then for the second task, it gets a bit more, not necessarily complicated, but it requires a bit more thought, as we now, instead of just getting the amount of winning numbers, the amount of winning numbers now add new cards to the list of cards we need to check. Meaning, because card 1 has 4 winning numbers, we will then add an extra card 2, 3, 4, and 5 to the pool. And we there exponentially grow the amount of cards, and then slowly adding. So now we have 2 card 2s. So now we need to add more card 3 and 4s, but then we do it 2 times because we have multiple cards and so on. And I decided to do this the simplest way I could think of, which is kind of brute forcing it, where we simply just have a queue of cards to be processed. At first, this cards to be processed is going to be containing an stream of all the cards. And we're then just simply gonna use part 1, where we just, on each card, simply first get the index of current card, which means first is going to be index 0, which is going to be the first card in the list. Then we're going to process it, meaning we find the amount of winning numbers. In this case, it's going to be 4. And we then simply just add cards to visit to the cards to be processed list. So we just simply first find all the cards we need to process and add them to the list, and we just keep going. And that's like this simple implementation. And why it very quickly become apparent is that this is very, very slow. Because in my case, I have about 19 million cards I need to process. So it takes about 43 seconds. But to then optimize, I added a memory management system, more or less, where first time we see a new card, we add them to this hash map. So now we know that card 1 has this result. So instead of, for the first card, it's not too much of a problem, but later on we might have like a million card 5s or a million card 100 or whatever. Then instead of actually calculating the result of card 100 times or a million times, we just simply find the result in this card memory map. Just believe me, it took 43 seconds, we can run it, but it's quite slow. But after this kind of optimization, we can see that it now takes me about 2 seconds. And I think that's very much the interesting takeaway from part 2. It's still relatively simple. We are just going through the cards, slowly adding cards to be visited to the list, and then just processing, just a lot of data. Yeah, I think that's all I think is interesting from part 2. Again, if you want to have a closer look, there'll be a link in the description to GitHub repository where you can look at all my solutions. But otherwise, I hope you enjoyed this bit shorter walkthrough of the day 4 part 1 and 2. If you did, please leave a like and subscribe, and I wish you all a wonderful